Okay, for section 2, we're going to find the y-intercepts using a graph and algebra. So first, find the y-intercepts using a graph. Well, if you can read the function. It looks a little trickier when it's written as a single fraction, at least to me it does. So I'm going to split it using that common denominator, because I can write negative 2x to the third over 3 plus 4 over 3 if I split it up. And then I feel like it's easier to graph. Negative 2x to the third over 3 plus 4 over 3. Like that matches that y equals mx plus b format a little easier. So if I'm going to graph this, first let's think about what does the parent function look like. It's x to the third power. Hopefully, in your mind, you automatically can picture a cubic function where it's from the origin, goes up to the right and down to the left. That is y equals x to the third power, parent function. And then we look at what's going on here. We have negative 2/3 x to the third. So negative tells me that I reflected it over the x-axis. Reflect over x. 2/3 is going to give me a compression. A vertical compression, compress by 2/3, and then plus 4/3. That's a shift up, because it's plus, by 4/3. Well, 3/3 is 1, right? So it's 1, and then I have 1 more third. So 1 1/3. And I'm reflected and compressed. So from the center, I'm going to shift it up 1 1/3. I'll call it about right there. There's my new center. And if it's reflected over x, that means what was pointing down is now going to point up. And what was pointing up is now going to point down. In this case, the compression doesn't really bother us too much. This is just a quick sketch. Like, I did not worry too much exactly what the shape looks like. Just got the main idea, quick sketch of what I'm expecting. And then, now that I've sketched my graph, I'm looking at the instructions again. Find the y-intercepts using a graph. Can you find the y-intercept using the graph? Do we know what it is? We do, right? Because we just shifted from 0, 0 up a distance of 4/3. So that means there's the y-intercept, and it is at the point 0, 4/3. Zero 4/3. So I found my answer. However, these instructions say to do it 2 ways. So there's by graphing, and then I also need to find it using algebra. Okay, well, we have the point 0 4/3. Why did we put a 0 for the x value? Because it's the y-intercept, and that's what you do. It's always 0, right? So if we use that information, if x is always 0 for the y-intercept, we could just plug in 0 for x. And if we did that, now we're finding f of 0 equals negative 2, plug in a 0 to the third power, plus 4. All of that is over 3. And if we evaluate at 0, 0 to the third power is just 0. 0 times negative 2 is still 0, plus 4 over 3. So that equals 4 over 3. And look at that. We got 4/3 for our y value when x was 0, and it's exactly the same as what we got by graphing.
Neat.
I know, isn't it wonderful how math works out nice and neat like that?